Hello everyone, I'm Dan. In this tutorial I'm going to give you an introduction to registers. Let's begin by opening up your web browser to my website, thegpu.com, and we'll scroll down here to assembly language. Select the Introduction to Registers option. So in this tutorial I'm going to introduce you to the first four general purpose registers, and I'll go over what that means in later videos, but there's a lot to take in. Now also I will introduce you to the concept of disassembly of the final executable. Now the most common processors found in servers, desktops, laptops, and many other things for that matter are the x86 and x64 processors. Now the industry is dominated by Intel and AMD, and they both support the x86 instruction set. The x86 architecture is the most widespread. Now registers are locations in the processor where it can access data, perform operations, and then store resulting data. Data contained in registers can be moved and manipulated extremely quickly. Registers are by far the fastest form of quote-unquote memory in the entire computer. Now each core in a processor has its own registers, and each core can perform multiple operations on a register per clock cycle. Now the typical memory hierarchy, ordered by speed in a modern computer, works like this. So registers, they are super fast, they perform operations, they're located on the chip, and each core has its own set of registers. L1 cache, now it's the fastest of true memory storage, located on the chip, and each core has its own, and it's located just outside the registers. Okay, and registers level 1, level 2, they're really expensive as far as the pricing of this memory goes. Now the L2 cache, the second fastest of true memory storage, located on the chip, and each core has its own, and it's just outside of the L1 cache. The L3 cache is the third fastest of true memory storage, and it's located on the chip, and each core shares this memory. Okay, so if you have like an 8-core processor, then you'll have each core will have its own registers, its own L1 cache, its own L2 cache, but then all 8 of them would share the L3 cache. Okay. Now let's talk about RAM. RAM varies in speed, but it's slow compared to registers or cache, and it's located on the motherboard. Obviously, if you're taking my tutorial, you're probably familiar that you have to clip it in and so on and so forth, and it must communicate over a bus. An SSD, slow compared to all of the above, right? And magnetic, your old platter hard drives, they are crazy slow compared to all of the above. So, let's talk a little bit about register sizes. Now, the very first x86 processors started out as 8-bit, and subsequent generations expanded to 16-bit, 32-bit, and 64-bit, and I imagine someday this tutorial will be obsolete when they move to 128-bit. But anyway, this progression led to a certain overlapping in the names of the registers. Okay, so the very first register, it's called the accumulator, right? And notice how it starts off with an A here, okay? So in the 8-bit, there's an 8-bit high and an 8-bit low, and so it's called AH and AL for the accumulator low and accumulator high. Now 16-bit is the AX register, once again, accumulator. And it contains just basically the high bits plus the low bits, total of 16 bits, right? But it's referred to as the AX register. Okay? So these two comprise this. Now the 32-bit register comprises the AX register, which comprises that, right? And it's called the EAX, right? And then the 64-bit register is called RAX with the R prefix on there, but it's comprised of the 32, the 16, which is comprised of course, these two registers here. So, and of course, there's 8 bytes in a bit. So a 64-bit register would be 8 bytes long, and the 32 would be 4, 16 would be 2, and obviously here's a byte and here's a byte, right? So talking about this, right, they just kind of overlap and encompass each other. Now, with that being said, the second one is called the counter. Notice the C, RCX, ECX, CX, CH, CL. So it follows some sort of logic here. So it's interesting anyway. The third one is called the data register. Notice the D, RDX, EDX, DX, DH, DL. And the fourth one is called the base. RBX for the 64-bit, EBX for the 32-bit, BX for the 16-bit, and BH and BL. Now, sometimes when you see these registers, you might be like, oh, wow, we can actually spell it A, B, C, D, and maybe that's the order they go in there or something. And that's kind of a common misconception there, but that's not the case at all. Just happens to be that. And this is the order they actually go in. But sometimes you'll actually, I prefer to actually code when, like, if I'm moving stuff into the registers, I'll actually do like the, the EAX first, followed by the EBX, the ECX. But anyway, that'll be a little bit more down the road. Now, what we're going to do today is we're just going to kind of explore how this all works there. So HXD for Windows is by far my favorite hex editor. You can download it here, pause the video. I'm not going to go through that there. It's fairly simple there. And for Ubuntu, I'm going to use WX hex editor, right? And here's the command you can install there. Open up terminal, install that. And then when you start, I recommend starting it from the applications window. All right, let's go ahead and dive in and do some code here. I'm going to go ahead and basically just minimize this here. Actually, what I'm going to do is I'm going to copy this here, okay, first. So let's go ahead and copy this code, and then we're going to paste it over into the virtual machine here, the Ubuntu virtual machine. All right, so the first thing we'll do is we'll just go ahead and open up terminal. We're going to make dir assembly. All right, now I already have that folder, but if you don't, it'll create it for you. And then we'll change directories to the assembly folder. And then we're going to make a folder here today called reg intro. And let's mix up my Windows commands and Linux commands there. All right, and let's go ahead and change directories to the reg intro folder here. And we're going to leafpad reg intro.asm. Okay, and then we'll just simply come over here and paste that stuff in there. So this is like a bare minimum program. It just starts up and exits out. This is the equivalent of saying like C or C++ of, basically doing int main and then returning 0. This is exactly what that does, and I'll go over that in just a second here. So let's go ahead and just save this. Let's open up another terminal. The reason why we're opening up another terminal is because you can't access the command line there while that's running. We'll change directories to the assembly folder. We'll change directories to the reg intro folder. And now we'll assemble it using NASM. Okay, we've got our .o file there, and now we'll link it there. -m elf i386, and O, and our output file will be reg intro. Okay, do an ls, and there we've got our executable there. Let's go ahead and just run it there. Of course, it's going to just basically do absolutely nothing. All right, so if you've got hopefully you've got the hex editor installed. If not, pause the video, get that installed. Let's go ahead and open it up there. It's a little funky when you open it up because you'll have to like kind of adjust these panels accordingly. But the first thing you want to do is come up here and go to View and do Disassembler panel and make sure that's checked. Okay, and then let's go ahead and open up the reg intro here. All right, and you'll have to kind of, if you play with this window here, it's a little funky to get it kind of aligned there. But basically what we want to do is we want to have the hex numbers 0 through F listed up here on this column just to make stuff just a little bit easier. Okay, there we go. Now it's all aligned. So we basically have 2 bytes across each one there. All right. So MOV is an operation code, or in other words, an opcode, right? And what I'm going to show you here is kind of how this works on the raw level. Since we're looking at the final executable, this is machine language right here, right? The assembler, NASM assembles it, LD links it, and we end up with machine language. These are the raw instructions for the x86 architecture here. Okay, when we run this program, basically the CPU basically just starts at the top here and executes everything from top to finish there. But let's go ahead and take a look at some certain things right here. Okay, so if I come down here to B8, right, I happen to know that B8 is the move instruction for for the EAX register. And so we're moving 1 into EAX. And that happens to be this right here, B8, followed by the next. Since B8, we're dealing with 32-bit architecture here, right? This is the value for 1. And never mind that you might think 1 will be over here. I'll explain why 1 is over here in a future video. But this is the value right here. So B8 says, hey, we're going to move the value 1, which is like this is the operation code here. And this is the actual argument, right? And you can see over here in the disassembler panel, move EAX, and then, it's got the hex value of 1 there. I could have put the hex value of 1 up there as well, too. Move EBX. Now, EBX, the operation code for that there, right, is BB, right? And then INT. You might be looking at this going, all right, chances are if you're tackling assembly language, you have some knowledge of other languages there, and this almost looks like, hey, C or Java or whatnot there, or C++, we're declaring an int 80, but that's not the case at all. INT in assembly is short for interrupt, okay? So we're calling interrupt 80, right, which is basically we're going to execute a system call here, right? When we move 1 into EAX, this is actually the equivalent, and by the way, comments are actually, they have a semicolon in front of them as opposed to C, which ends the line there. So this essentially is a system call, right? Sysexit, right? And this right here is basically its argument, right? So when we call interrupt 80, it says, oh, what's in the EAX register? Well, that's sysexit, and then we're going to pass the argument, the parameter, whatever you want to call it, depending on where it's going into. But anyway, whatever. This is the equivalent of return, and this is 0 for its parameter, and this tells it to actually execute the whatever command is loaded into here, right? For example, if we had 4 in the EAX register, that would be the equivalent of syswrite, right? We're going to write something or other there. Anyway, I'll go into that in future tutorials. Probably maybe recognize that from the welcome tutorial there. But what we want to do at this point in time is just leave our 1 there, right? Which is our sysexit. And let's take a look at some of these other registers here, right? So before we do that, we're just going to do some silly little stuff here, and I'm going to move EAX1, and I'm going to move EBX2, and I'm going to move ECX3, and move EDX4. All right, let's go ahead and save this. We'll come back down here. And we'll just up arrow and hit this again there. Assemble it. Link it. And, we can run it. It won't actually still do anything. But what we are looking to do here is let's go ahead and we'll just close this and reopen it. Reg intro, right? And looking at our first B8 right here, right? There's our opcode, and followed by the parameter 1. EBX is BB, right? 2. You can see over here in the disassembler panel too. B9, right, is ECX. BA, followed by the 4 right there, is EDX. And then you can see the next thing we do is we move 1 back into B8, right? We move 0 into BB. And then we do this CD80 right here, which calls the interrupt 80, okay? So if you, as you get familiar with this, right, you'll be able to go into stuff and look at it, and it really is critical understanding this really machine language stuff here. If you want to get really, I don't know, hardcore on this stuff, you can get to the point where you can just basically open up a hex editor and you can just write machine language if you wanted to, and executable, and then run the thing. So without any sort of a assembler, linker, compiler, you name it, right? So anyway, let's go ahead and pop over to NASM to finish this tutorial out here. I'm going to open up Visual Studio. And we'll do a new project. C++, we're going to do an empty project. We'll just call this one Reg Intro on the assembly folder there. Okay. All right. So what we're going to do is come in here. We have to set our build dependencies. We check NASM. And now we set some properties here. Oh, just popped over in this window here. First of all, we're going to pop over to System, and we're going to set the subsystem as a console. And we're going to go into Advanced. We're going to set our entry point as Start. And we're going to scroll down to... wait, we're going to cancel on this. First thing we're going to do, right, let's back that up, is we're going to change the this to release, okay? And we got to come back here and do all this stuff again, build dependencies. Okay, that's still good. Properties. Let's go over to System, Subsystem, Console, Advanced. Our entry point is going to be Start. And down here, Image has safe exception handlers. We're going to select No on that and apply. All right. All right, source files, add new item. We're just going to call this regintro.asm. Okay. And let's pop back over to here, and we'll just cut and paste this stuff right in there. Okay, we can, for example, stick a breakpoint right there and run this thing. It'll pop up into the window here. There's absolutely nothing to this, right? If we continue on, boom, we're done, right? But we want to come up here to build and then build reg intro, okay? Succeeded, bada boom, bada bing. All right, I've got a HXD shortcut here down on my taskbar. I'm going to just pop that open here. And let's go ahead and open up that executable. It'll be under assembly reg intro in the release folder, and here it is. As you can see, it's got significantly larger than looking at it on Ubuntu there. So it's just got a lot of bloat in here. But let's go ahead and search for the hex value of B8, which we know is the EAX, move EAX opcode there. And let's hit F3 to find the next instance of it, and F3 again. Okay, so now we've got the BB02. So over here in the source code there, right? Same sort of stuff, move EAX, EBX, EDX, right? So, but then of course, the exit process is a little bit different over here on Windows there. But you can see the same Same stuff in the machine language over here on memory there, or in the hex editor there for Windows there. Anyway, that basically about concludes this tutorial there. I'm going to basically on the next video, I'm going to go into a little bit more about the, not just the EAX registers, but the AX registers, the ALs, and so on and so forth there. Anyway, that concludes this tutorial. Thanks for watching.